Our last topic in the Chapter 6 review is exponential functions as mathematical models. Okay, so invariably what you're going to find here is the kind of problem where they're going to give you a word problem, but it's going to have a couple of values in it. So they might say it's an exponential model, and at for an input x, we'll get some output y. So let's say they tell us at some value of 0 we'll get out 2, and then later on at some value of 5 maybe we get out 12, and tell us that this is an exponential function. So once again, you have to get this data from the word problem, and then the word problem also needs to say that it's an exponential model. So then we know it has to fit into something of y equals a times b to the x. And what we do is we plug in the values here. Okay, so the y is 2 and the x is 0. So we say y is 2, x is 0. We know that b to the 0 is 1, so this is just a, so 2 equals a is what this leads to, or a equals 2. Okay. Now we take that fact and let's plug in the 5 and the 12. 5 for x, 12 for y. So now we're going to say 12 equals a, we already know what a is, which is 2, times b to the x power, which is 5. Okay. Now we're asked to solve a problem, but notice it's not an exponential function, because it's the problem that we're solving here is just fifth order b. We're looking for the base, actually, what b is here. So first thing we want to do is divide by 2 on both sides. We get 6 then is equal to b to the fifth. Now what we want to do is reduce that b to the fifth to b to the first, because we're trying to find out what is b. So to do that, remember exponent, a power to a power, we multiply this. So this on the right side is just going to be b to the 5 times 1/5, which is b to the first. But whatever we do to one side of the equation, we have to do the other. So we take a fifth root of 6 over here. So now we have b on the right side, and this one's going to be the fifth root of 6. Okay, that obviously hard to do by hand. Let me grab the calculator. Take 6 to the 1/5, or 0.2 power, gives us, we'll do that again, gives us 1.43097. So we write that down. We get b then equals 1.43097 approximately. And now our overall equation, putting this all together now, is y equals a, which is our initial value of 2, times b, which is 1.43097 to the x power. Okay. And once again, if I plug in 0, I should get a 2 out. And I put a 0 in for my x here. This whole term will go to 1, and we're going to get y equals 2, which is what we were looking for up here. Okay. If I plug in my second point, y 12 equals 2 times this 1.43097 to the x power, but our x is 5 this time. We should find out that that is true. So our general exponential equation, or specific exponential equation, was that. Okay, and the rest of the problem will basically say they'll give you some output value, like at 140, and asks you what's your input value at 140. Okay, so you're going to set y equal to 140 and solve this thing, very similar to what we did to find b. And the other problem might be that they give you a value of x as being 10 and say what is the y value. That's an easier case because we just plug that into an exponential equation here. So that one would give us y would be 2 times, let's do it this way, 1.043097 to the 10th power, and you would just put that in your calculator and get the resulting value. So I'd recommend that you look over a few of these. The book has tons of them, evens and odds, and you can also find some in Math Excel. All right.